Okay, this is a statement of the distributive property. This symbol is an equal symbol. There's not a direction to distribution. It's not you don't only start with this and then wind up with this. You can go the other way as well, and it's still the distributive property. What people say is, if I have something that looks like this, I can distribute, and I will get this. On the other hand, if I start with this, people say that you can factor and wind up with this. In either case, it's the distributive property. But these are the words people use. I'm going to distribute the A, or I can factor out the A. And it is a property of the real numbers. It holds for any A, B, and C. And on the discussion board, the fifth thing that you're asked to do, so you have to describe what is a additive inverse. Excuse me. You have to describe what is an additive identity, what is a multiplicative identity. What is an additive inverse, what is a multiplicative inverse. And then the fifth thing is for you to verify the distributive property. You will make a similar argument to what I am about to make here. If your argument doesn't have all of these pieces, it's incomplete. Either that, or it'll have a circular reference. You'll be using the distributive property to tell me that the distributive property holds. You can't do that, right? If you want to verify that distribution is a real thing, then you cannot use distribution in the course of your work. It has to just be shown at the end of it all that it must be the case. So, Rosalinda, pick for me 3 integers, 3 numbers. I don't care if they're integers. Any, random, go, ready, set, go.
5, 3, 6.
5 times 3 plus 6. I need to simplify each of these statements all the way down to a single number. And I have to do it without using distribution. And if they come out to be the same number, then I will have shown that this and this are the same thing, which is what it means to have distributed the 5. Right? So, on this first one, how can I simplify this without using distribution? 3 plus 6 is 9. You do the part in the parentheses. So I would be looking at 5 times 9, and that's 45.
And then 30, 15, 45.
Yeah, so down here, multiplication takes precedence over addition. You do the multiplication first. That way we're not doing something silly like adding the 3 and the 5 first. So 5 times 3, that's 15. 5 times 6, that's 30. They're being added together. It equals 45. And since they both came out equal to 45, then it must be the case that the two expressions I started with were equal to each other. I didn't use distribution here. I was able to show that these two statements are equivalent because they're really just the same number. So then these two things are the same. Now, distribution has been verified for where A is 5 and B is 3 and C is 6. To show that it was true for every real number, you'd have to do every combination. There's a way to do that. It's called with mathematical induction, and we won't bother with it. That's why you are just asked to verify that it holds for some random 3 numbers that you pick. Okay. Questions on discussion board?
So on this part, whenever we're doing it on a discussion board, it'll be in number notation like this, or we'll have to write it out?
You just do this right here.
Okay.
So you started with something that looked like this, where it's a number times this quantity that's a sum. And you just do the part of parentheses first, and you get that. But down here, you have what that would look like if you distributed the 5. But we don't know that distribution is going to work just yet. By the time we simplify this and get the same number, well, now we know that distribution must have held for these numbers. And then you just make a statement like this. So when you commute somewhere, you have to move your body from point A to point B. You're going over there. But it's still you, right? Your house is still the same even when you're not there. And work is still the same even when you're not there, or whether or not you get there. So if I'm at my house, then work and home are still just the same buildings, whether or not I'm in the first one or in the other one. And it's kind of the same thing in math. We say that the real numbers are commutative. That both addition and multiplication are commutative. It's the statements that A plus B is the same thing as B plus A. 5 plus 3 is the same thing as 3 plus 5. Either way, it's 8. The same follows for multiplication. A times B is B times A. It didn't matter if it was 3 times 5 or 5 times 3. Either way, it's 15. That's commutativity. It's not discussed on the discussion board, but it's worth pointing out. The other one that's important is associativity. If you had two friends that you were going to meet for lunch, and you needed to go pick them up in your car, then it doesn't matter if you went and picked up friend A and then went and picked up friend B, or if you went and picked up friend B and then friend A. In either case, you're all in the car and you're going to all have lunch together. And it's the same thing here. We say that addition is associative. It doesn't matter if I first add A and B and then add C, or if I add B and C first and then add A. It's all the same. 1 plus 2 plus 3, it won't matter in what order you do it, because it's always just 6. Addition is associative. Multiplication is also associative. It doesn't matter which pair you do first. You're all going to wind up in the same place. In either case, you get 6. Now sometimes there's an additional statement made here that, well, if these two are going to be equivalent, and it doesn't matter which pair I add together first, then I could just write this without any parentheses, because it's all the same operation. Right? There's no multiplication being mixed up with addition, so I'm not having to worry about that precedence. So you could just write this 1 plus 2 plus 3 with no parentheses. You could drop it. Same thing down here. It's all multiplication, so you could just ditch the parentheses. There are there's an intuitive understanding of absolute value, and then there are 2 rigorous definitions. Our intuition tells us that if it's a negative number, you take the minus symbol and you throw it in the garbage. Just forget about it. Example, the absolute value of minus 2. These vertical bars mean take the absolute value. And if I have this intuition, then I'll be looking at my minus 2 and saying, it's got a negative, so I'm going to throw it away. Then this just must be what? 2. The definition your first working definition of absolute value is that if I have the absolute value of some quantity, it will be that same quantity if it is greater than or equal to 0. On the other hand, if that quantity is less than 0, then I should take that symbol and put a minus in front of it. See that that definition works for us here. If I have the absolute value of minus 2, then according to my rule, minus 2, that's less than 0. So I should take the minus 2 and then stick a negative out front. So this would be the negative of minus 2. Now that's a multiplication of two negatives, so it's positive. We good? A quick introduction to roots. We cover roots in depth in, I think, weeks 7 and 8. But on this first assignment, there are some square root questions. So I guess for now, we just need to talk about square roots. And pretty much all you would need to know for now is, can you solve something like this? What number does this have to be? This has to be the number 8, and the reason being is because 8 squared is 64. So just like you had minus built out of plus and you had division built out of multiplication, the definition of the square root is going to fall back on what it meant to square something. And I guess I should have mentioned about exponents before doing that. The exponent is delicate. In this course, and for pretty much anything that you're going to need to do, it's not true. For every week of this course except week 8, all of our exponents are integers. And when that happens, if your exponent is an integer, then exponentiation has a basic definition. If I have some symbol and it has an exponent of n, this is defined to mean that symbol getting multiplied together how many times? N, many times. So, and that's if n is an integer. And what is an integer? Kinda. The whole numbers are 0, 1, 2, 3, 4, 5, and so on. The integers include all the negative ones also. So it's like minus 3, minus 2, minus 1, 0, 1, 2, 3, and to infinity in both directions. That's an integer. And I guess for this definition, you're actually right. I should just say whole number. Because with this definition, it wouldn't make sense to have minus 2 of these things. We will be able to make sense of something like x to the minus 2, but that will come next week. Don't confuse exponentiation with multiplication, because if you have some quantity multiplied by a whole number, then that would just be the addition of all of these. And how many would you have? You would have n many. And that's very different from having the x's be multiplied. And you have n many. And each of these statements are where n is a whole number. Don't think that this means that multiplication is built out of addition. It's only coincident with this statement when n is a whole number. Because what if I said, 1/2 times 1/4? Then I couldn't just write half of an x, Definition of multiplication of two fractions. A over b times c over d is just the quantity a times c over b times d. It says that if I had two fractions being multiplied, it's the easy thing that you want to do. You want to just write it with one division bar where the numerators are multiplied and the denominators are multiplied. So multiplication of fractions is the easy one. Addition of fractions, a little harder. But there's no need to make a fuss out of it. It has an easy definition. It is the definition. There's not, so there's like these different strategies, find a common denominator and all this. If you do what I'm about to write, it's the answer every time. The definition is, just trace out where all these symbols go. It's a times d plus b times c over b times d. There's nothing to it. 5/3 plus 8/7. I just picked them out of thin air. I want to add them together. You can do it like that. It's 5 times 7 plus 3 times 8 over 3 times 7. You have turned a addition of two fractions problem into a problem involving 1, 2, 3 multiplications and an addition. which you can do. 5 times 7 is 35. 3 times 8 is 24. 35 and 24 is 59. 3 times 7, 21. They're added together. All right, now I'm going to open up the homework assignment. And we will do it from the front to the back. And I think I've talked about everything that's needed to get it all done. So look at where I'm going to get to my assignments. Yeah, you could go here to assignments. I think it's not as good as what I'm going to do, because if you click assignments, then it will try and open up your assignments, and that's poorly named. I need to go through and rename it. Oh, look, they fixed it to open it in a new window. That's nice. It used to be the case that it would open it here. And the design of this website that we're going to utilizes like half of the screen for just garbage, and then the problem is just down here. You can't see what's going on. So it's better to click My Lab and Mastering, and then click this yellow button, and it takes you natively to their website, where you can review other assignments you've turned in, like if you want to study for a quiz or whatever. You can see every assignment that you've submitted. And then here I will click on assignments and pick. I did relabel them. It's just not. So if I look here in assignments, there's not a week 1 homework. That's false. This is week 1, and you have homework this week. It's this assignment. For whatever dumb reason, they have it named in the week it's due instead of the week you had the class. So then I change them to not have a week associated. It's just the first one and then the second one and so on. And the due dates are right here. January 30th, that's next Monday. Homework 1, 15 questions. And you're lucky because the online class has twice as many questions. I don't know about lucky, but and the reason I would say that is because having only 15 questions doesn't quite adequately prepare you for the quizzes and the midterms. You have to do a little bit more studying than just 15 questions to feel prepared. This is an archaic symbol. Avoid it at all costs. In some cases, depending on the order of your various operations, you can arrive at the correct answer even without making a conversion. I would strongly suggest, that you always just have the same technique. And what this says is that I have this plus this other thing, and I want to convert this so that it's nothing but multiplication over here. So I would say that to divide by 6 is to multiply by 1/6. And then I have only my addition and multiplication. 30 times 1/6 times 8. So in this example, you could have just said 30 divided by 6, that's going to be 5. Right? And then 5 times 8, that's 40. But if if I divide by, okay, so there's this like famous meme that I've seen before. See if I can recall what it said. People will get in shouting matches over this problem. How did it go? It was like, I don't know, 1 plus 2 divided by 3 plus 4. Let's just say. I'm sure this wasn't the same thing, but. It was actually, hold on, it was I can't remember. 2. I'm still screwing it up. I can't remember how it goes. Does anyone recognize what I'm talking about? That stupid meme? And people would argue, is the answer 1 or is it 9? It went, I can't remember how it goes. But you can construct a problem such that if you use that stupid division symbol and don't make the conversion I'm talking about, you'll get the wrong answer. Maybe I'll think of an example here in a moment. This one is not a problem. And I'm pretty sure that the situation is because there's no addition happening over here, and it comes first. I would have to play with it for a minute to build a problem where it failed. At any rate, these are equivalent. Yes?
What's the course ID for the Pearson?
Why?
Is it supposed to just go automatically when you click it?
Yeah. What happened?
Like, if I have to sign in, and I didn't have an account, so.
So you started in Canvas, right?
Yeah.
And then you clicked the yellow button, and it took you to Pearson's page to sign in.
I'm sorry, I don't know.
Now
if
you got
it's
it?
worked before. Okay, thank you.
It happens. No problem. Anyways, you wind up with just two terms being added. And by the way, you don't have to raise your hand. I'm not that formal. Just shout out something. This winds up being this sum. We do our multiplication first, and then our addition, and that's why the terms, we'll call them terms, are separated by the plus sign. So this problem has two terms. Each of these would be called factors, and then these are the terms. And then 58 plus 40 is 98.
So how did you get 40?
30 times 1/6 is 30 over 6. Okay? Which is 5. 5 times 8? 40. I'm going to remember what that stupid problem is here in a minute. Okay. Problem 2, simplify the expression. Use the order of operations. Grr, nothing makes me madder than a stupid order of operations. It's not a real thing. And that dumb problem I'm trying to think of is gotten wrong by so many people because they think that this is math. This is not math. This is bogus. This is worthless. In math, we just have our notation so that we can communicate with each other. We say that the parentheses should be respected to house a single object. So if I'm talking about 1 plus 2 in parentheses, then I'm talking about the number 3 right there. These parentheses house a single object. And then, given our definition of the exponent as just being repeated multiplication for now, multiplication would take precedence over addition. So that's why the next thing that you pay attention to is the exponents, because you're just breaking it down to look like multiplication. And then it's multiplication before addition, which is just a worldwide convention so that we can all read each other's work without having a million sets of parentheses in every statement. So you do not need to think about anything to do with order of operations. What you need to think about is, so if you're going to use some silly acronym, it needs only be these 4 letters. And this isn't even 4 things to remember. It's 3 associations. It's parentheses and then exponents. Exponents becomes multiplication, multiplication before addition. Respect the parentheses first. Okay. Well, there's nothing going on in here except for a -1 times 2. And they have it written as this quantity -2. Great. Handle the exponent then to convert it to a multiplication. That would be the quantity -2 times -2 times minus 2. This is just saying 18 minus 3 times 9 minus negative 2 times negative 2 times negative 2. There's nothing going on here but addition and multiplication. These three terms being multiplied comes out to what? Negative 8, and then there's another negative here, so this will be a positive 8. That term will just become 8. 3 times 9, okay, and it needs to be negative, so this would be minus 27, and then there's 18. This problem has 3 terms. You could have seen them from the outset. The first term, the second term, the third term. Okay, so when I'm doing this, it's going to be more convenient for me in my head to add the 18 and the 8 first. That'll get me up in the 20s. And then I can compare a 27 and a whatever more easily, right? And what property is that I'm trying to use there to add the 18 and the 8 first? Associativity, right? All 3 of these guys are going to lunch, and it doesn't matter who you pick up first. So I'll do the one that's convenient for me. 18 plus 8, that's 24. So this is 24 minus 27. Well, now I can easily see the answer, right? Oops, what did I do?
Sorry, what did you do? You added
18 plus 8 is...
26,
Yeah.
not 24. 8 times 3 is 24. I don't know what I was doing. 26. Thanks for warning me so late. Just kidding. 26 minus 27. Oh, it's even easier of a comparison.
I have a question.
Yep.
How did you get 8 for the 2s, the negative 2s?
Focus on 2 things. The first thing is what's the sign? The sign. So how did we say negative 2 got constructed? It was minus 1 times 2, right? So this is minus 1 times 2, minus 1 times 2, minus 1 times 2. It's all a product. Commutativity says I can rearrange that however I want. So let's rearrange it as minus 1 times minus 1 times minus 1 times 2 times 2 times 2. Now 2 times 2 times 2, you can figure that out. It's 8. The minus 1 times minus 1 times minus 1 is an odd number of minus 1s. Since a pair of minus 1s being multiplied must be positive, then by being a pair, that's an even quantity of them. Right? If I have an even quantity of them, then I can form pairs. But if I have an odd quantity, I can still form pairs, but there's one left over, and it'll switch it back to being negative. So then this quantity must be like an 8, and then the 3 minuses make it be negative 8. But out here there was a 4th negative. That's an even amount of them. So then the sign of this thing becomes positive, and the magnitude, you would say, is 8.
Where did your 26 come from?
26 came from the 18 plus 8. I did 18 plus 8. So I said to myself, I don't want to think so hard about 18 minus 27 because I might get confused. I ended up still confusing myself, but y'all helped set me straight. 18 plus 8, and then minus 27 was what I just preferred to do. You don't have to, but I did. What do those vertical bars mean? Absolute value. So there's, they're like parentheses that do an extra thing. So these absolute value bars have gathered together this single object in here. But we know what 7 minus 8 is. We can simplify that object. 7 minus 8 is minus 1. And then the absolute value of minus 1 is positive 1. And positive 1 times 6 is 6. And which property is that? That 1 times 6 is 6. Yeah. So this term is 6. The other term is 18 over 2, which is 9. It has only the two terms. 6 minus 9 is minus 3. Rosalinda, tell me what to do on this problem.
This one,
Multiply each.
first you,
What is the fact I need to invoke to move forward?
no, you're multiplying 17 by C.
No.
Minus 17.
Look more carefully at this.
Uh-huh.
In the big picture, what am I needing to do? Not a specific thing. Don't say, take this and multiply it by that. What is the name of the property that I should use? The distributive property. I need to distribute what quantity?
Minus 17.
Minus 17. The minus 17 needs to distribute to both of these terms. And what is this other term over here? So here's a C, and that's
A D.
negative D.
Negative D.
This says C plus negative D. So when I distribute the negative 17 over here to the negative D, what am I going to get?
Positive.
Positive.
So it will be negative 17
Times C plus 17D.
D.
They want us to fill in the box, whoa, down here. This expression can be simplified, and it is what we have written, minus 17C plus 17D. Simplify the expression. So this is the first place where I can start this list. Here's this list. I'll be writing it over and over again for several weeks. Number 1, distribute. Number 2, combine like terms. There is a 3 and a 4. We'll talk about that when we get there. And it's just those 4 things. And those 4 steps solve any equation, any linear equation. First, you need to do your distribution. Why do I need to do that? I gotta respect my parentheses. Because these parentheses have gathered together this object as a single thing. It's this one dude, 5k plus 3. And I need 3 of them. But I don't have any other way to simplify this statement unless it's going to just be a sum of terms. And then I can combine like terms. What does it mean to be like? It means that your variable has the same exponent. That's all it means. Same variable, same exponent. So, when I do my distribution, I would get 15k plus 9, and then just write down the rest of it, minus 19k plus 8 plus 4. Then the terms that have the k are alike. K is just some number. I don't know which one, but I have 15 of them right here. And over here I have a minus 19 of them. And when you add those two together, minus 19 and 15, you get minus 4. So it must be the case that this comes out to a minus 4k. And then all the rest of them are just numbers. 9 plus 8 plus 4. That's 13 and 8 is 21. We good here?
Wait, how did you get to 21?
9 plus 8 plus 4.
Okay.
So I have this, it's all mixed up. I'm invoking associate commutativity because then I want to have the 15k minus the 19k. I'll do that first. Call it minus 4k. And then I want to do the 9 plus the 8 plus the 4, I get 21. This is the problem I was talking about when I said earlier that some big proportion of people would get this wrong because of misinterpreting that little line. The parentheses gather together these symbols to turn it into a single object. So you have minus this object. And how would I have taken such an object and converted it to be the negative of that? Or just reinterpret this minus right here, and you can't go wrong. What does it mean to have that minus right there? Yeah. This needs to be viewed as 14 plus a negative 1 times 3y plus 8. Or else what would happen is people would just throw the parentheses away. Can't do that, because that's a minus. It says minus 1 times this. That minus 1 has to be distributed in. This is 14 minus 3y minus 8. Then 14 minus 8, that's 6. And then the minus 3y is all by itself, no like terms, so minus 3y plus 6. All right, it's 8 o'clock. Let's take 10 minutes. Or it's 8:02. We'll take 10 minutes. And when we come back, we'll do the rest.
Will you go back to question 1,
Mhm.
please? Sorry, I was trying to get my stuff to stop glitching.
Mhm.
Sorry, did you do the multiplication of 6 times 8 before looking at the quote-unquote division, if you will? We just verbalize quickly how you went through that. Because I'm probably gonna mess it up if I didn't know.
Okay, so
Or would you?
it's confusion. Do I do this first? Do I do this first? There wouldn't be any confusion if it was all multiplication.
Right.
Okay, so rewrite it that way.
1/6 times 8, 30 times 1/6 times 8.
Yeah,
Okay.
you have 58 plus 30 times 1/6 times 8. When it's all in the same operation like that,
Really simplifies it.
yeah, you can't make a mistake, because then you're invoking associativity. You can do whichever you want.
Cool.
8/6, that's 4/3, all right?
And
4/3 of 30 would be 40.
And technically 30 would be over 1, 8 would be over 1.
Always.
You know what I mean? And then you could just go across and multiply the tops and then multiply the bottoms.
You could. I wouldn't.
Right, I'm just thinking,
And why wouldn't I here?
Just kinda
Because I'd want to take advantage of any cancellation,
symbols. Yeah.
right? So the 6 and the 8 can cancel. That would be 4/3.
No, just.
Okay.
Okay? The 30 and the 3 can cancel.
10/1.
10/1 times 1/1 times 4/1. The answer is immediate. Yeah. This is a better strategy than coming back up here and saying, okay, 30 times 8, that's 240, and then 240 divided by 6. Because I don't want to do 240 divided by 6.
Yeah. I just think of, that's how I do my math indexes. So my brain goes to that.
Yeah.
But, okay.
I mean, it will get you the right answer, but it will become inconvenient to do it that way shortly, because the numbers will be so large.
Cool.
And furthermore, when we get to rational expressions, we will absolutely need to do that cancellation in order to solve the problem. Okay, so yeah, I couldn't recognize it earlier, but this example is exactly a problem where if you didn't tend to the division symbol first. No, it's still okay. Never mind. No, it's not. $30 divided by 48. Now here, let me write it like this. 30 divided by 6 times 8 is different from 30 divided by 6 times 8. These are different. Because this one's 40, and that one's less than 1. It's 30 over 48. Definitely ain't 40. And somewhere along the way, in the last 15 years, somebody just basically wrote the book wrong and started teaching it that way to America's youth. And they taught everyone that if I was given this right here, oh no, I'm sorry. So what I have here is just fine. That's a fact. And here would be one that is a mistake. Dang it. Somewhere along the way, people would say, oh, you don't have to do the multiplication before the division. And that's only sometimes true. The problem is fixed when you quit thinking division is its own thing and you just have multiplication. Convert everything to multiplication and then there's no problem. So this statement right here has you not going from left to right. This business of going from left to right is garbage. That's not a thing. You may do it in whichever order you would like. That's associativity and commutativity. But there's got to be an example. I'm going to figure it out right now. So if I did the multiplication over here, then This is that stupid problem. And what ended up happening is that somewhere along the way, someone tried to make, they tried to make it easier for people to do the problem correctly. And all that ended up happening was they ended up teaching them incorrectly. Because they had to invoke this idea that you always needed to go from left to right, and it didn't matter which one you did first, multiplication or division. That's false. The real problem here, the real culprit, is the use of this symbol. This is for people in elementary school. Don't use this. And the problem that people are having is that they would say, okay, I need to go from left to right, just like my teacher taught me. Then I'd say 6 divided by 2, that's 3. And then it'd be 3 times 3, which is 9. This is not 9. You can see that it can't be 9 because if I did the distribution of this 2, here's 6 divided by something. Distribute the 2 into here, and you'd have 2 plus 4. And now it says 6 over 6, which is 1. And that's better. But the ultimate correctness is if you want it to be 9, you need to say this. And if you want it to say 1, then it either already did say 1, or now there's absolutely no doubt that this one would be 1 and that one would be 9. And the original problem was just ambiguous by use of that. This symbol has a name. It's like obelisk or obelisk. It starts with an O or something. All right, are we all here? Time for me to quit goofing around. Let's finish our homework. So now I can say that 4-step process that always solves a linear equation of one variable. Number 1, you distribute. Number 2, you combine like terms. Number 3, you use your additive inverses. Number 4, you use your multiplicative inverses. If you had to make sense of this list, it would be the order of operations backwards. Or it's not even backwards, it's just in the same ordering. Distribution has to do with a quantity in parentheses that needs to be respected. And skip that. Let me think. Actually, it's only this part, and then it is backwards. Because when we're reading our notation, we always do multiplication before addition. But in the course of solving the equation, I'll have to unwind any addition that's going on and then unwind any multiplication that's going on to isolate that variable. I'm looking here at this equation. Well, there is no distribution. You can skip that part. Combine like terms. This combine like terms refers to on just either side of the equal symbol. I look on the left side of the equal symbol. Can I simplify it by combining like terms? No, there's nothing to combine over here that's alike. And on the other side, it's just one term, so there's really nothing to combine. So distribution is done. Combining like terms is done. Now I need to use additive inverses. I want to solve for the AX. It's got something being added to it. Add to both sides the additive inverse of 18, which is?
8x.
8x is not the additive inverse of 18. What is the additive inverse of 18? Negative 18. Because 18 added to negative 18 is 0. When I add negative 18 to both sides, then right here, you get 0. It would now say 8x plus 0. I don't have to write the plus 0 part because of the additive identity. 0 is the additive identity. 8x plus 0 is 8x. So this left side just becomes 8x. And the right side becomes 2 minus 18. So now I can combine those like terms. You get minus 16. This guy with the x doesn't have anything else being added to it anymore. Now you know that additive inverses are done. Time to move on to multiplicative inverses. Your goal is to solve for x. There should just be how many x's? One of them. So really, I want it to say 1 times x. Because if it said 1 times x, then by the multiplicative identity, that would just be x. So can't I multiply on both sides by the multiplicative inverse of 8? The multiplicative inverse of 8 times 8 is going to be 1. And the multiplicative inverse of 8 is 1 over 8. So you would multiply on both sides by 1 over 8. But that means the same thing as to just divide by 8. And now you have it. X is a minus 2. Now in this problem, you're given 3 options, A, B, and C. And I would like for you to recognize the trichotomy of these 3 options, that together they comprise every possibility. Option A is talking about a solution set. The solution set is, and we can put in a number here. And the number I should put in is this minus 2. A set is a collection of numbers. It's a bucket with numbers in it. And it's indicated by these curly braces, they're called. And the number that goes in this bucket here is a -2. Okay, so my solution set can either contain some numbers, or option B, my solution set can contain all of the numbers, or C, my solution set is empty and contains no numbers at all. None, all, some. This circle with a line through it diagonally is not 0. It's the set equivalent of what a 0 is. 0, the number 0 is meaning an absence of quantity. And this symbol here is meaning a collection which has no members. My fan club is an empty collection. My collection of exotic sports cars is empty. I don't have any. So that's what this means. It is an empty set, not a 0. And for us, the answer is just going to be this number 2. Don't write x equals the number 2. Don't write x equals -2. You just want the number -2. If you put x equals -2 right here, then you're saying that the solution to that original equation is another equation. Well, that can't work. I can't go back up to this original. If the answer was going to be x equals -2, if that was what I should type into the box, then it would have to be the case that 8 times x equals -2 plus 18 is 2. Now, I don't even know how to interpret this. It doesn't mean anything. Because I have here an equation. Equations wouldn't go here. Just the number -2 would go here. So correspondingly, my set of solutions has just numbers, not equations. Distribute, combine like terms, additive inverse, multiplicative inverse. It solves all these equations every time. Well, there's no distribution. We're off to the races. Combine like terms. I look on the left side, there's no like terms to combine. Are there any like terms to combine on the right side? Yes, these 6x and -8x, right? And if you rigorously wanted to see why that had to be -2x, you could factor the x out of these two terms, and it would say x times 6 minus 8. So it's -2x. These two combine together to give you -2x. So then on the right side, I would have -2x plus 6, and on the left is still what I started with. Combining like terms is done. Use additive inverses. Use additive inverses to gather together all of the x terms on one side and all of the number terms on the other side. Doesn't matter which one. Right? So I'll put my additive inverse of 4x on both sides. When I do that, this will become a 0. Huh?
Oh no, I'm just thinking.
This would become a 0. Because it's -4x plus 4x. Okay, well, the other additive inverse I need is -6. Because -6 plus 6 is 0. Then I have the numbers on one side, the variables on the other. It just also happened to be the case that on this side it's going to add up to 0 as well. That wasn't my intention, it's just how the problem is working out. So we have that 0 is equal to 2 times a number. What must that number be? 0. You can always verify that you have the correct answer by coming back up here to the top, substituting a 0 in for x. Now in this problem, you can plainly see that 0 must be the solution when you substitute it back in. Because when I put the 0 in for x, it's just going to wipe those out. It's literally going to say 6 equals 6, which is true. So 0 is a solution. It's the only solution. Here we'll finally get to distribute and then combine like terms, use additive inverses, and then multiplicative inverses. So when I distribute, I'll get 6t minus 9. It's equal to 18 minus 3t. The distribution is completed. There aren't any like terms to combine. Remember, you're just looking on either side of the equation. If you want to start shuffling terms to the other side of equals, you need the additive inverse. So, this side has got a 6t and a minus 9. Suppose I left the 6t there and did the additive inverse for the 3t on both sides. Then the other additive inverse I would need is for this minus 9. I would have to add 9 on both sides, with the effect being that right here, this adds up to 0, and right here, this adds up to 0, and I can read off what the next equation is going to say. It's going to say 9t equals 27. Additive inverses are done. If you don't like that, you can always do it in 2 steps. But there's really no need to. It's a one-step sort of thing. And you can see that the quantity that I added to each side is the same. In both cases, the thing to add was 3t plus 9, 3t plus 9. And that wiped all the addition out. There's no more addition happening. So you move on to your multiplicative inverses. You would multiply both sides by the multiplicative inverse of 9, which is 1/9. Last time I said it was division. It's really the same thing. This time I'll go ahead and use my multiplicative notation times 1/9 times 1/9. 9 times 1/9, that's 1. So this left side now quite literally says 1 times t. And according to the multiplicative identity, 1 times t is t. So it's now solved for t. It is solved for t, and the other side says 27/9. But 27 has 9 as a factor, doesn't it? 27 is 3 times 9. So this is 3 times 9 times 1 over 9. And 9 times 1 over 9 is 1. So the final answer is that t must be 3. T is 3. Or you could have just realized 27 divided by 9 is 3. It's the same thing. Our solution set then is not the equation t equals 3. It will count it wrong if you type that in. And somebody in here is going to do that on the quiz. Don't let it be you. Just put the number. That's all it wants. T is 3. Oh man, there's fractions to add. What a bummer. No, it's not. It's super simple. It's nearly trivial. We have a definition of what it means to add two fractions. You don't have to even think. You just have to follow the definition. I'll help you recall what it is. A over B plus C over D must be, by definition, A times D plus B times C over B times D. So if you just trace out where all the symbols go, then you can rewrite this as 3 times x plus 5 times x over 3 times 5. And it's equal to 8. It is a rare occasion that if I have to add two fractions that I'll do anything different than this. There's only one instance when this is not as convenient as it could be. And that's if the denominators have common factors. If the denominators have common factors and you use this to add the fractions together, then you'll have to reduce it. It's not that big of a deal. Reduce is the wrong word. We quit saying that. We say simplify. Reduce has the connotation that somehow it changes value. No, it's the same value. It's just simplified. Okay, so look, it's just this numerator times that denominator plus this one times that one. And then the denominator is the product of the two denominators. Right? It goes like this times this plus this times this over this times this. That's all I'm doing. All right, so we get 8x over 15 equals 8. Now, before you haul off and start simplifying this thing and then wind up shocked at the answer, doesn't this just say 8 times x over 15 equals to 8? It does? This is a statement about a multiplicative identity. I took this number I multiplied it times something and got the identical number. So it must be the case x over 15 is the multiplicative identity. This x over 15 is 1. And if x over 15 is 1, then what's x? 15. Now, maybe you didn't realize that and you're working on it at home, whatever. You could use your multiplicative inverse. You'd be multiplying both sides by 15 over 8. Here's where you really would want to multiply and not divide by something. Because how inconvenient is it going to be to divide by 8 over 15? You'll mess it up. You want to multiply both sides by this reciprocal, 15 over 8. That's all the multiplicative inverse is. It's the reciprocal of whatever number. If I have 5, then 1 over 5 is the inverse. Here you have 8 over 15. The reciprocal, 15 over 8, is its inverse. Because when you multiply on both sides by 15 over 8, then the 15s cancel, the 8s cancel. It has to, because it's the inverse. You get 1 times x, which is x. On the other side, the 8s cancel, and the 15 is all that's left over. If you find yourself multiplying 15 times 8 in the course of solving this problem, you are wasting your time. There's no need to. The more correct way that will be more beneficial to you is to do any appropriate cancellation first. Always take advantage of that cancellation. If you're not doing it, it's like leaving money on the ground or something. It's not as obvious here with just some numbers, but later on when it's like polynomials and you're not canceling them, you'll get a headache. So x must be 15. On one of the discussion boards, I think in week 6, this observation that we made right here, that this number was acting like a multiplicative identity, that observation will come in very handy that week. Whoops. Solve for h. I'm going to do the same old thing. Distribute, combine like terms, additive inverse, multiplicative inverse. There's nothing to distribute. There's no like terms to combine. Great, we're half done. Additive inverse, I'm wanting to solve for h. There's something being added to the term that has the h. Use your additive inverses to send it to the other side. So the additive inverse of 5z minus 5z. I can always construct the additive inverse. I just tack a minus symbol on the front. Minus a 5z on both sides. You get s minus 5z equal to 5h. There's nothing else being added to the term with the h. You're done with additive inverses. Time for multiplicative inverses. I would like it to just be a single h, 1h, 1 times h. So I should get out my multiplicative inverse of 5. I should multiply on both sides by 1/5. means the same thing to divide both sides by 5, whichever way you want to look at it. Now, on this right side, that's 1 times h, which is h. So we now have that h is equal to 1/5 times s minus 5z. So I could distribute that 1/5 into here, and I would have s over 5 minus 5z over 5, which is just z. It will also happily accept the answer s minus 5z over 5. They're the same thing. Multiplicative inverses are finished when you're just down to the variable, and the equation is solved at that point. So, it says that h should be, and I'm going to type something, and before I hit enter, you're going to tell me if I'm going to get it right or wrong. It's wrong. What's wrong with it?
Because you say capital.
Huh? The capitals. The capital Z is not the same thing as a lowercase z. They are literally different symbols. So it's going to count it wrong. Over here they used lowercase. I need to use lowercase. What did I do?
You're supposed to say
Isn't it supposed to be
s minus.
It's minus,
5.
not a plus, right?
Is there a difference if you put a 1 over 5s minus z?
It shouldn't be. It should still accept that, no problem. So, because you'd just be saying a number times s minus z. This is exactly the format of a linear equation whose slope is 1/5 and whose y-intercept is z. We'll discuss that at length next week. So I anticipate it would still take that. Capital letters. It has capitals. You use capitals. This is also a linear equation. Y equals mx plus b. It has exactly that form. And they're wanting you to solve it for r. Two steps, and this problem's solved. Right? Because it's distribute, combine like terms, additive inverse, multiplicative inverse. There's no distribution, there's no combining like terms. We can jump straight into additive inverses. I want to solve it for r. There's something being added to the term with the r. Use additive inverses to get rid of it. Subtract a 17 on both sides. It would now say m minus 17 is equal to this number times r. Additive inverses are done because there's nothing else being added to the term with the r. Now you use multiplicative inverse. This is 7/3 r. I wish it said 1r, because then 1r would just be r. I can force a 1 to appear there if I multiply on both sides by 3/7. So I will multiply here by 3/7, and I will multiply over here by 3/7. This would now be equal to r, and this is what I'm going to type in for my answer. You don't even have to distribute it. You can, but you don't need to. It already has the r equal. If you put r equal also, it will count it wrong. It just wants you to type in this stuff. And you could distribute it, but I'm not going to. Mostly because it's inconvenient for me to find 3 times 17. I don't want to do it. It's 51, but whatever. 3/7, and then times the quantity, capital M, minus 17. We all good? Only 3 more problems to go. This is a linear equation. It will be the object of study next week. By the way, next week is the hardest week of the course. So if you've got next week, you're good for the rest of the term. But it surely gets a little more serious, a lot more serious next week. (5x plus 7y) is 35. They want me to solve it for y. There's something being added to the term with the y. What should I do? Yeah. We should subtract the 5x from both sides. Because minus 5x is the additive inverse of 5x. And when they add up to 0. And so that left side says 0 plus 7y, which is just 7y because of the additive identity. We would now have 7y equals to 35 minus 5x. There's nothing else being added to the 7y, so I am done with additive inverses. Time for multiplicative inverses. I need the multiplicative inverse of 7. It's got to just be the reciprocal of 7. It's 1/7. So, let us multiply on both sides by 1/7. Then on this side, it now says 1y, which is just y. On the other side, I'll distribute my 1/7 inside. I don't really know if it would, it says simplify your answer, so I think it's going to want us to. Well, now I wonder what the instruction in the last one said. It also said simplify your answer, and I didn't distribute it. I wonder if it would take that. I'm going to try. It does. If we were trying to write a line in slope-intercept form, like what is so popular for next week, that's the y equal mx plus b format, then obviously you would want to distribute that 1/7. And if you did, you would have 35 over 7 minus 5 over 7x. And 35 over 7 simplifies. It's what? 5. So the slope of that line is minus 5 over 7, whatever a slope is. And the y-coordinate of the y-intercept is 5, whatever that means. We'll talk about it next week. And keep in mind that if you're asked to simplify something, it's not always clear what that means. One person's simplification is another person's complication. You may either have something factored as a product, or you may have something written as a sum. This is a product. I have this number, 1/7, times this other thing. This is a multiplication of two things. But when I distribute it, now I have a sum. I have this plus this. Who's to say one is simpler than the other? You can't. So instructions like simplify are not always clear. Questions 14 and 15 are word problems. So when you have word problems like this, you should start with drawing a picture. You should write down everything that it's telling you, converting it from words to math equations. Here we have a building with a rectangular base. So I'm drawing a picture of that rectangular base. Here's my rectangle. Rectangles have lengths and they have widths. And we are told that the length of this base which is L, measures, that means it equals 65 feet less than twice the width. Well, the twice the width is 2W. Twice the width is 2W. But to construct a quantity that is 65 feet less than 2W, I should take 2W and subtract away 65. Now, this number right here, it has, if that wasn't there, it would just be 2W. But this guy has got to be 65 less than 2W. So the length must be 2W minus 65. We're told that the perimeter is 800 feet. Perimeter is the length around, it's the distance around the whole figure. So 800 has got to be L plus W plus W. It's 2L plus 2W. But this is a variable, or this is an equation of two variables. Can't solve it. Infinite number of solutions. There's an infinite number of ways to have a length and a width such that the perimeter could be 800. Until you factor this tidbit in. There's only going to be one such rectangle that satisfies this and this. So substitute in this, what is 2W minus 65? It's L. So rewrite this, and instead of putting L, put this. So we'll have that 800 is 2L plus 2W, where L is 2W minus 65. Then this literally says that 2L plus 2W is 800. But look, now it only has the one variable, W. So I can solve it. I can solve it and get a unique answer, a single unique answer. How do we solve it? Distribute, combine like terms, additive inverse, multiplicative inverse. I'll distribute the 2. I will combine the 4W and the 2W. I will add 65. I will multiply by 1/6. So distributing the 2, we get 4W minus 130. And then here I still have my 2W. Combine like terms. You have 800 equal to 6W minus 130. Combining like terms is done. Additive inverse. I need the additive inverse of 130, of minus 130. Well, that's a positive 130. So if you add 130 to both sides, then you would have that 930 is 6W. Right? Divide both sides by 6, and you are finished. (930) over 6 is 155. So W is 155. Now they're going to ask me for the length. What am I going to do? I need to use this fact right here, that 2W minus 65 is the length. And now I know W. It's 155. So the length must be 2 times 155 minus 65. The length is going to be 2 times 155 minus 65. And so that'll be 310 minus 65. So it's 300 minus 55, so it's 245.
I'm sorry, can you repeat the link one again? I can't really see
It's at the very top now. Can you see it?
that. Yes.
So the length, being that it came from this equation, that it was 2W minus 65, then we found that the width was 155, so this is 2 times the width minus 65. And 2 times 155 is 310. And then 310 minus 65, I'm trying to find a good spot for it. There's just not a good one. That's as good as I can get it, or I can rewrite it over here. So 2 times 155 minus 65, that is 2W minus, that is 65 less than 2 times the width. That's what L was. 310 minus 65, which is 300 minus 55, right? And 300 minus 55 is 245. Say what? 310 is what 2 times 155 is. Because 150 times 2 is 300, and 2 times 5 is 10. That is an application of the distributive property. 2 times 155 can be thought of. You should make practice of doing this instead of reaching for a calculator. You will eventually get just as fast. Even to the point where you will have done it faster than if you looked for your calculator and typed it in. 155 is just 150 plus 5. Well then, by distribution, that's 300 plus 10. It's trivial. And then when you have the 310, and you want to take away 65, you're really saying, or I'm thinking, that this would be 310 minus 10 minus 55. So it's 300 minus 55, which is 245. Okay. Last problem is a very similar word problem, but with a triangle. Draw a picture. Now, they tell us what the perimeter is. Evidently, it is a huge triangle out in space, because you can't draw such a triangle on the surface of the Earth. Its interior angles would not add up to 180 degrees because it's on a sphere. So, such a triangle, this would only work if it was in a flat plane. So, there we are in deep space with a triangle whose perimeter is 3,081 miles. It has a shortest side, it has a middle side, it has a longest side. It is scalene. All three sides are different. So draw such a triangle that has a short side, a middle side, a long side. They've told us about the perimeter that the sum of the three sides is 3081. That's the short plus the middle plus the long. But then additionally, the shortest side measures 67 miles less than the middle side. So I'll take my middle side, there's my middle side, I'll deduct 76 miles from it. Then that quantity, m minus 76, is 76 miles less than the middle side. The middle side is just whatever it is. And then the longest side measures, which just means equals, 373 more than the middle side. So here's my middle side, and I'll glue onto it 373 more miles. This is what the short side is. This is what the long side is. So I can rewrite this equation, but instead of using S and L, I can use what they are in terms of M, and have an equation in one variable. So there's S plus M plus L. Nothing but addition going on here. I put the parentheses here so you could see that this was quite literally S, and this was L, and now it says S plus M plus L. But the associativity property says that we don't need those parentheses. They're not actually doing anything because it's all addition. Okay, so there, the parentheses are gone. Now what?
Then you combine like terms.
You should combine like terms. So, M plus M plus M, 3M. 373 minus 76. Okay, that's 373 minus 73 minus 3. So it's 297. It's still equal to 3081. Additive inverse. multiplicative inverse. Additive inverse of 297 is a minus 297. So I need to subtract 297 on both sides. So 3081 minus just 300 and then plus 3. So that's 2784. Is 3m. Now I know, let me scoot this up. I know that this number, 2784, is going to be divisible by 3, evenly. And I know this because there is a trick that we will exploit at length in the future that says that a number like this one, 2784, is divisible by 3 if, when you add up its digits, that number is divisible by 3. So 2 plus 7 is 9. 8 and 12, or 8 and 4 is 12. 9 and 12 is 21. 21 is divisible by 3. Since 21 is divisible by 3, then we are guaranteed that so is this one. So, of course, that doesn't help me know what the answer is. It just tells me that for sure it's divisible by 3. So I'll know that the middle side must equal 2784 divided by 3. And how would I tackle that? Without a calculator? What's 2784 divided by 3? Figure it out. 9 what? 928? Did I get it right? Okay. And then that's just what the middle side is, but that isn't the first question they're asking. The first question they're asking is what is the shortest side? And then they're going to ask what's the middle side, and then the longest side. So let us figure out what the shortest side must be equal to, because that is m minus 76. That's 928 minus 76. So it would be 908 minus 56, and then that's 902 minus 50, so it's 852. Am I right? And then the middle side of 928, and then the longest side, which is the middle side plus 373. So it would be, the longest side is 928 plus 373, and you get 12.
1301.
Huh?
1301.
Say it again?
1301.
1301. All right. That's it. That's the assignment. You can expect the quiz to be just like it. I mean, not just like it. There'd be no surprises, is what I'm trying to say. If it was just like it, then they would have called it homework 1.
Can we go back to question 8?
Yeah. Okay, so it kept giving you what? All right, can you read it to me what it says?
6 minus 3x equals 5x minus 10x plus 12.
Okay. Combine like terms, yeah, distribute, there's nothing to do. Combine like terms,
So that would be -5.
negative 5x plus 12 is equal to 6 minus 3x. Okay, do an additive inverse.
Are we doing the x's or?
Doesn't matter.
Okay.
Pick one and do it.
Let's do add 3x.
You want to add 3x. Okay. There, I've added 3x. These will add up to 0. Okay. Over here, it's going to be minus 2x. Fine.
And then let's subtract 6 on both sides.
If you do that, it'll say 0 equals some other stuff.
Okay, see, that's what I was doing. Okay.
And then you would have to do something else, right? So we're always trying to move towards isolating that x term.
Okay.
The minus 3x and the positive 3x, they added up to 0. You designed it that way.
Okay.
Okay? Since you worked on this side, don't do the additive inverse on that one. Do the additive inverse on this one. Because then these will add up to 0. And what will our equation say? We'll say minus 2x equals to minus 6. Now you can divide both sides by negative 2. X is 3.
That's what I was doing, the same side. Okay. It makes sense.
Any other questions before we adjourn for the day?
Did we just save it once we finish?
It should save like as you go, right? Every time you submit an answer, it's saved. I think even if you type something in the box, it saves it, even if you didn't submit it. Like you could close the lid and open it up later and it's gonna be there. And there's no like submission of the homework. Your grade just gets updated continuously. So once you know, if you just stop working on it, well then that's your grade. But if you finish it and there's 100, well then your grade will be 100. Or 30 or whatever it'll be the maximum. Yes,
So it updates on its own.
yes. It doesn't update instantly. Takes, I don't know, 20 minutes, but it will do it. All right, next week, it's gonna get more serious. So bring your thinking caps. Discussion board initial post, Friday. Minimum 2 replies, Sunday night. No, Monday night. Your attendance is linked to it. So don't forget, I will see you in a week.
The first step, I didn't know how to check in. I didn't add my absence or no.
So you didn't get checked in at all?
No, I did it.
You didn't?
After about 40 minutes.
Oh, okay, yeah, yeah. So, let's get it fixed. What's your name?
Salmon.
Samala?
Salmon. A-M-A-N-E.
Okay, hold on.
I need to write it.
No, I can figure it out.
Yeah.
What's your last name?
Call me up. K-A-M-Y-A. The hardest name.
The hardest name. All right, let me restart my computer and we will fix it.
I wanted to ask if I retake this, the piece, it changes my